Hi, we are Group 10. My name is Jess, and we will be presenting on SMIC together with my group members, Chai Boon Kiat, Chong Wei Xiang, and To Wei Xiong. For the table of content, we have, first of all, the introduction of SMIC, strategic challenges, external analysis, industry analysis, internal analysis, 5-year strategic plan, and conclusion. So for the introduction, first of all, SMIC stands for Semiconductor Manufacturing International Corporation. It is the largest semiconductor company in China, Shanghai, which was founded in 2000 by Richard Chang. It is one of the leading chip manufacturers globally, and it specializes in integrated circuits for a wide range of applications that includes appliances, vehicles, and communications. It is entirely owned by China Integrated Circuit Industry Investment Fund. Strategic challenges faced by SMIC, first of all, will be the US sanctions. SMIC was added to US restricted trade list and has been the target of US sanctions since 2020 for alleged ties to the Chinese military-industrial complex. Since then, American businesses are required to apply for a license before they can sell to SMIC, restricting its ability to acquire certain US technology. Secondly, manufacturing limitations. SMIC is unable to obtain extreme UV lithography machines, and without this, they cannot produce more advanced semiconductors on a large scale at a lower cost. Thirdly, supply chain issues. Spike in e-commerce spending increases the demand for semiconductors, but there was a shortage in the market during the COVID-19 lockdown period. Through COVID-19 pandemic, it highlights the vulnerabilities of the semiconductor industry.
I will be talking more about external analysis. For political, US and China trade tensions heavily impacted on SMIC as they face export restriction. SMIC also faces limited access due to advanced manufacturing equipment such as EUV lithography machines due to the restriction and pressures Netherlands face from US. For economic, semiconductors demand remains strong during high trends like AI and 5G. Geopolitical tensions disrupt supply chain as production priorities shifts due to trade barriers and export controls. This results in economic uncertainty and rising costs. For social, China's digital evolution includes cutting-edge technologies such as AI, 5G, IoT, and big data. This upgrades its economy and society. Business like e-commerce and digital payment are integrating these technologies to create better models while increasing efficiency. And most importantly, such technology requires semiconductors. For technological, China patents activity have notably increased in 2021 to 2022. 55% of global semiconductor patents applications were Chinese in origin, and China number of applications doubled America. However, significant gap remains as semiconductor industry R&D intensity shows that China rate of 7.6% was just 40% of America 18.8% and below European firms 15%. SMIC likely stand 5 years behind global leaders such as TSMC due to the limited access of advanced manufacturing equipment, particularly the EUV lithography machines. They are able to only produce 7nm chips, which lags behind Samsung and TSMC, both of which began producing 3nm chip as far back as 2022. For industry analysis, the threat of new entrants are low due to many big firm presence. This industry requires extensive research and development, making compliance very difficult for newcomers. In order to contend with economies of skills and idea generation, this requires a huge amount of cash. The bargaining power of suppliers are high due to SMIC heavy dependency on specialized equipment such as EDA tools and photolithography tools, many of which are supplied by foreign companies like ASML and Applied Materials. However, due to US sanctions of limitations to suppliers, dependent and costs are increased. The bargaining power of buyers are moderate to high as there's a chip oversupply. This risks on weakening demand. New production capacity will also increase price competition, while investors are betting that AI development might not need more advanced chip, which will benefit chip makers like SMIC. The threat of substitute is moderate as US impose export restriction on the ability of advanced chip from leading foundries like TSMC and Samsung to Chinese customers. This removes the immediate threat of substitution for SMIC in the domestic market. However, despite advancement, SMIC lag behind leaders like TSMC and Samsung in producing cutting-edge chip. While SMIC has achieved 7nm chip production, companies like TSMC and Samsung have progressed to 3nm technologies. This technological difference means that for high-performing application, SMIC may not be the direct substitute for global competitors. The industry rivalry is very high, although 80% of revenue comes from local market as there are fierce competition with other big firms like Samsung and TSMC. They still lag behind big firms when it comes to global market due to being in the US trade blacklist since 2020. SMIC also face aggressive pricing pressures from domestic rivals expanding their capacity, leading to a price war in the commodity chip segment.
Turning to SMIC internal capabilities, the VRIS framework highlighted how the company sustained its competitive edge despite external pressures. SMIC value creation is anchored in two strategic advantages. First, it designed as a core tech project by the Chinese government in 2024, provides unparalleled financial stability and R&D funding critical for sustaining mature node productions that dominates its revenue stream. Second, its foreign partnerships exemplifies forces as synergy under sanctions, With dedicated Shanghai production line for Huawei 5nm smartphone chips, SMIC guarantees revenue stability while advancing China technology. This interdependency, where Huawei relied on SMIC due to broad access to TSMC, turns geopolitical constraints into strategic value. However, this value proposition has limits. As noted, SMIC's inability to mass produce 3nm, 5nm AI chips without EUV tools, which handicaps China AI sectors against NVIDIA and AMD. Should domestic firms like Byron demand cutting-edge nodes, SMIC's current capabilities could become a liability rather than an asset. SMIC demonstrates what we call sanction-driven reality, competitive advantages forged through necessity rather than choice. The crown jewel in the DUV-only 5nm process, an engineering marvel that no other foundry, not even TSMC with its EUV access, has chosen to replicate. This breakthrough, achieved through advanced multi-patterning techniques, has become SMIC's signature capability since being cut off from ASML EUV machines. This forced innovation has yielded tangible results. Despite operating under strict US sanctions, SMIC captured the world's third global foundry positions in 2024. Consider the ironic, while Intel Foundry benefits from the CHIPS Act, subsidies yield at rank 5. SMIC has leveraged Chinese domestic demands to achieve what no other sanctioned semiconductor firm has accomplished. However, our analysis reveals this reality comes with expiration dates. This technological gap is widening, where TSMC is mass producing 3nm chips and developing 2nm nodes, where SMIC remains stuck at the 5nm threshold. The workaround solutions, while impressive, face diminishing returns at smaller nodes. This creates a strategic dilemma. Can SMIC transition from being a unique constraint to genuinely competitive in advanced node race? This answer will determine whether SMIC's current reality becomes a stepping stone or a ceiling in the global semiconductor hierarchy. SMIC's third competitive advantages lie in its costly to imitate capabilities. Advantages so resources intensive that competitors simply cannot replicate them. The numbers speak for themselves. In just 1 year, SMIC received $372 million in government subsidies. This isn't occasional aid, it's a systematic state backing with billions invested to fast-track chip development and productions. The private foundries can match this subsidy-driven capital expenditure, giving SMIC an unmatched ability to scale rapidly despite market conditions. The Huawei partnerships exemplify these advantages. SMIC non-substitutable stems from two critical advantages. First, as Huawei's sole domestic supplier of advanced nodes, it maintains a monopoly-like position. Under Pulse 2024 reports, confirmed SMIC will mass-produce 5nm chips for Huawei despite low yields and high costs. No other Chinese foundries can manufacture less than 14nm logic chips, and global competitors like TSMC are blocked by the US sanctions. Second, government interventions create an artificial market. SMIC receive 80% of China's chips subsidies, while companies like Huawei and Xiaomi face pressure to buy domestics, even when SMIC chips are costlier and slower than global alternatives. Yet, this advantage is fragile. SMIC's entire business model depends on sustained US sanctions. If the restriction is eased, Huawei would likely to abandon SMIC for superior TSMC chips, exposing SMIC technological lag. This creates a dangerous paradox. SMIC is simultaneously protected by the geopolitical yet vulnerable to geopolitical change, a reality that tests its long-term viability.
Let's look at SMIC's 5-year strategic plan, starting from this year, 2025. The first step is to reinforce its leadership in mature node chips such as 28nm and 45nm. These chips are still in high demand, especially in automotive industries and industrial controls. By focusing on its strength, SMIC can secure reliable revenue while avoiding the more restricted advanced nodes. In 2026, the company aims to finalize its 5nm process technology. This is a big move, even though they are doing it without access to EUV tools. By using advanced DUV equipment and partnership with local firms such as Huawei to push forward, although it will cost more, but it will give them a competitive edge at home. By 2027, SMIC plans to deepen collaboration with domestic tech leaderships such as Huawei, Expert Motors, Luxshare Precision, and CATL. Their joint work on chips such as Mate 60 Pro already shows what is possible. At the same time, SMIC wants to boost its R&D spending to improve yield and reduce costs over the long term. By 2028, SMIC's goal is to scale up its 12-inch wafer production capacity to meet demand across several high-growth areas such as AI and EV chips. As more companies shift away from foreign suppliers, SMIC has a unique opportunity to fill the gap with its domestic production and chip costs. and by 2029, the focus can turn towards achieving technological independence. China is already developing its own EUV system, and SMIC will play a key role in bringing them to market. With those tools, they will be able to manufacture more advanced chips without relying on the existing global supply chains. If all this is successful, the final phase of the plan will help SMIC compete directly with major foundries such as TSMC or Samsung, both in terms of production scale and technology efficiency. Over the next 5 years, SMIC plans to strengthen its position in mature node manufacturing while progressing towards developing its 5nm chip capabilities. The company's strategies focus on expanding local partnerships within China, improving research and development efforts, and investing more efficiently to meet the rising demands for automotive and AI-related chips. Although SMIC faces challenges from export restrictions and technology access issues, it is taking steps to build resilience through domestic innovation and steady capacity growth. Looking ahead, SMIC's strategic plan shows a clear commitment to achieving greater technological independence and capturing a larger share of the global semiconductor market. These moves will be important not only for SMIC's long-term growth, but also for supporting China's broader goal of building a self-sufficient technological sector. Thank you.